Use the factorization A equals PD P inverse to compute A raised to K, where K represents an arbitrary positive integer. K could be 1, 2, 3, 4, 5, etc. Here A is equal to given PD P inverse. So if we square it, if we multiply A by itself, let's multiply. So when we multiply A times A, we get A square, A times A. So we need to multiply PD P inverse by itself, PD P inverse. Okay, matrix multiplication is not commutative, so we cannot just move and find the product P inverse. But P inverse is just identity matrix, but we cannot just move. But the matrix multiplication is associative, so we can write in this way: PD P inverse, then P D P inverse. So we can group them. Now P inverse P is just identity matrix. Okay, so identity matrix times D is just D, and we got D together, so D squared P inverse. Okay, so A was given PD P inverse, we multiplied by itself, and we got P D squared P inverse. If you look at closely, only this D is being squared. P and P inverse are still there. Let's do one more time. If I multiply by A, or if I multiply by A, then I get A cube. I'm multiplying by A means this one, okay? So P D squared P inverse is already here. I'm multiplying by A. A means this, P D P inverse. Again, matrix multiplication is associative, so we can multiply these two. So P D squared, if we group them together, then we have P inverse P, which is identity matrix, and D P inverse, which is P I times D is just D squared P inverse. So what we found here is now A3 is just, sorry, D squared and D means this is D3. Okay, so A is P D P raised to negative P inverse, that was given. So when we had 1, here is 1. We multiplied both sides by A, means A squared, and we got 2 here, here is 2. Okay, then when we multiply one more time, A3, then this P3. So in this way we can say A raised to K, it can be shown that A raised to K is equal to P D raised to K P inverse, K positive integer. Okay, now having this, let's go back and answer this. So this is A, this is P D P inverse. We just saw that if we have A equals P D P inverse, then A raised to K is P D raised to K P inverse. So from this one, this is A, so this raised to K, 2 2 1 1 3 1 1 2 2. So we are multiplying this itself K times, maybe K equals 5 times. Then it's so easy, all we have to do is multiply this, and this one P stays P. Okay, this one also P inverse, we just multiply this K times. So I don't have room here, so I'm moving this away. So this will be 1 1 2 1 0 negative 1 1 negative 1 0. And now we multiply k times, but this is a diagonal matrix, and when we multiply itself we just multiply diagonal elements. One more time, here we are doing k times, so this will be 5 raised to k, 5 times 5 times 5, and 1 raised to 1 times 1 times 1, always 1, and this is always 1, and we got all other zeros. And this matrix itself, this is 1/4 1/2 1/4 1/4 1/2 negative 3/4 1/4 negative 1/2 1/4. Okay, so multiplying, when we write a matrix in terms of diagonal matrix, then multiplying itself is just easy.